Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. Okay, so today we're not going to do circles for the first time in a long time. We're going to do some areas. So the first thing we're going to start with is areas of parallelograms. Areas of parallelograms. So pause the video, knock out this, write down all the important stuff, draw the pictures, etc. This is obviously very important, so write down all this stuff. This stuff appears on the ACT all the time, and so it also appears in higher level math. So we're going to start on this after we're done with our circles. All right, cool. All right, so what does this mean? All right, let's see. So let's go to our notes. Areas of parallelograms is our title for today. And so basically the area of any parallelogram, which means the opposite sides are parallel. So BC is parallel to AD, and then AB, 2 marks here because it's different set of parallel lines. AB is parallel to DC or CD. So if you have a parallelogram like this, then the area is always just the base times the height. Base times the height. What are the other parallelograms that you know? Yeah, you know, square, where all sides are congruent, and rectangle, bam, where opposite sides are congruent, bam, and also a rhombus, which is a parallelogram, looks like this, a little slant, where you have all the sides congruent. So rhombus is also your square, rectangle, and then you got a rhombus, where the opposite sides are parallel, and all the sides are congruent, so you got a rhombus. And then you have this as just a regular parallelogram. So all of these, as long as the opposite sides are parallel, then you have base times height to find the area. So that's what we're going to do. So in the example that it provides you, it says this is the height, which is 18, and this is the base or bottom, which is 30. So what is the area? Well, if it gives you this or anything like this, if it said this is like 20 or something, this is irrelevant because this is not the height. It's just this is the height. And notice how it makes a right angle here. So you have to look for that right angle for the actual height because that means it goes straight up and down, perpendicular to the base. So the area here is just 18 times 30 or 30 times 18. That's it. So we got 30 times 18, and we have 540 units squared. Because what is area again? Yeah, area is all the space inside the shape. Area is all the space inside the shape. So now let's do a couple examples. So we're going to do a few examples right here. So looking at your PDF or set up your paper. We're going to do 1, 2, 3, 4, 5, 6. We're going to do all these, okay? Of course, you can always pause the video and see if you can knock all of them out and then press play and see if you get the rest. There's always an option. So here we go. Boop, number 1. Always starts with the easy stuff. So here we got, so we're assuming these are parallelograms. That's what it says in the instructions. So we got 16 and 18. So it looks like the height is 16 and the base is 18. And so the area is just base times height, which is 16 times 18. Cool. 16 times 18. 16 times 18 is 288 units, feet squared. There's all the square feet. So it's all of that space inside that parallelogram. Next, now it's not going to be so easy. That one's really easy. This one's not so easy because let's see what it gives us. So it gives us 24 inches. It looks like this is a rhombus because all of the sides are congruent, but we don't have right angles here, so it can't be a square. So these marks mean that all the sides are 24. So I'm going to mark up my picture, always important. Mark up your picture. So you know the base, which is 24, but what the hell is the height? I don't know. So it gives you this, but I can also do this. So that also is the height. So the height is here, and look, there is a triangle we've made. This looks like a special triangle, don't it? So if this is 60, that's 90. This is 30 degrees. And so let's go back to our 30, 60, 90 triangle. So draw this off to the side. And if you don't remember to go back and look at your notes because you should have this in your notes somewhere. 30, 60, 90. So opposite the 30 is always just x. Opposite the right angle, the hypotenuse, is going to be 2x, double whatever that other side is. And then opposite to 60 is whatever the side opposite to 30 is times radical 3. So this is the pattern that exists in all of 30, 60, 90 triangles. So we know that the hypotenuse is what? 24, because we know that this and this are congruent. So that would mean that the hypotenuse is 24. So 2x is 24 there. So if I know x, then I can just plug it in here, and this is the height, right? This is the same thing, height, 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 height. So I'm just going to solve for x and put it next to radical 3. So that's going to be divided by 2. 2 times, 12. 12, so this side is 12 right there, but I don't need to know that. That's irrelevant to this problem, but I need to know this part because that's the height, 12 radical 3. So that ends up being the height because it's the same triangle. Cool. So the area is base 24 times height, 12 radical 3. So you get your calculator out, 24 times 12 radical 3, round to the nearest tenth. Area is approximately, because we are estimating, 498.8 to the nearest tenth. This is 0.83, but this rounds to the nearest tenth. Units, inches squared. Bam. Cool. All right, 2 down. Keep going. This is one's right angle. That would mean that all the other sides are right angles. This is just a square. This one's easy. So this is the base, this is the height, so the area is just 1.6 times 1.6, which is 1.6 squared. Easy, 1.6 squared is 2 56/100 centimeters squared. Always put your units right there. It's really gonna help you as you get to more complicated math. All right, so we got those. That looks pretty easy. Now let's continue. Now it's gonna get fun. All right, so now you got this kind of picture right here. So now we're going to do these ones. This is my awesome rendering of all these. 4, 5, 6. And it tells me that they're all right angles or rectangles, so we're assuming these are parallelograms. So all the instructions right there. Okay, so first one, I got to get the shaded region. Oh, but I don't know what that is. Well, no problem. Here we go. So it looks like this. So I need the shaded region. So what you would do is I'm going to find the area of the big rectangle there, and I'm going to subtract the area of the small. So if I take this out, then I just have the regular shaded region. So if I just do 32 times 16, that's the area of the whole thing. But if I take this area out, then what's remaining is all of this area right here. So area of the big minus area of the small, that's going to help us. So area of the big is going to be 32 times 16. Boom. And then I need to take out this part right here, and I'm left with what's shaded right there, the other area. So that's 12 times 5. Bam. And then calculate it up. 12 times 32 times 16 is 512. Minus 12 times 5, which is 60, minus 60 is 452 centimeters squared. Boom. Got it. Nice. Okay, let's try this one, number 5. Ooh, how are we going to do this one? Always try and pause the video, see if you can figure this one out. How do I find the area? That's all the stuff inside. That's not the perimeter, that's all the stuff inside. So what I'm going to do here is I'm going to break this down into smaller pieces. So I'm going to do so I got one parallelogram here. I'm going to go I'm going to have one parallelogram here and then one there. So I got 1, 2, 3 different parallelograms. I could probably do it this way if I wanted to and go 1, 2, 3. So each way works. Just make sure you are consistent with what you're doing and you look at all of the measures to make sure you're doing it right. So I'm going to do this way, 1, 2, 3, like this, like a cake. So this right here is 3 times 3. This is the area, 3 times 3, which is 9 feet squared. This right here, this 8 doesn't, no, it ain't 8. this whole thing is 8. So this part is not 8. So if I find the area of this middle rectangle, it's going to be 3. And then this part here is 3. And ooh, that could bring this down. So this is going to be 3 plus 3, which is going to be 6. 3 times 6 is 18 feet squared, is that one. Last but not least, we got this little tiny piece, tiny sliver down at the bottom. So this is 12 and 2. So base times height. This 6 has nothing to do with it. This 6 is just this part right here. The base is 12 times 2, which is 24 feet squared. And so now I have this area, this area, this area. So if I add them up, I got the entire area. Hello. 9 plus 18 plus 24 equals 51 feet squared. There you go. Easy. Oh, number 6. This one is very similar to the first one we just did up here. See if you can knock it out. See if you can do it yourself. Go. So this is the area of the big. Unpause if you already got it. And then just keep watching. See if you got it. Minus the area of the small. Minus the other area of the small. Because I got 2 areas I need to take out. So the whole area here, the whole space inside is going to be 30 times 18. Minus this part, which is 9 times 9, which I'm going to do in my head, 81 inches squared, minus this, 12 times 9, which is, 108 inches squared. So 30 times 18 is 540 minus 81 minus 108, because I'm taking out these 2 parts. These are the 2 small ones I need to take out, because I'm left with just the area around it. Minus 81 minus 108 is 351 inches squared. Cool. There you go. Nice job, everybody. So this is what you need to do now. So I did the first 6. So here you go. So you got 1, 2, 3, 4, 5, 6 right there, and then you got 7, 8. You got to do these ones right now. Check your answers on the PDF and knock out that exit quiz. Go work, everybody.